In this video, I will discuss about the design of FIR low-pass filter. A low-pass filter is to be designed with the following desired frequency response. Determine HD of e power j omega for m is equal to 7 using Hamming window. So here m is given, that is size of the window, that is m is equal to 7, and here it is of form e power minus j tau omega. Tau is given, that is normalized magnitude frequency response of the desired low pass filter is shown below, that is this is HD of e power j omega, its value is, so this is omega. So it is defined only between minus 3 pi by 4 to plus 3 pi by 4, that is let this be minus 3 pi by 4 and this is plus 3 pi by 4. Suppose this is pi and this is minus pi, and its value is 0 if omega is greater than 3 pi by 4 or greater than minus 3 pi by 4. The first step is, here now I will take the inverse Fourier transform of HD of e power j omega, that is taking inverse Fourier transform. I will write it as HD of n is equal to, we have 1 over 2 pi integration minus pi to pi HD of e power j omega, HD of omega or HD of e power j omega, both are same, e power j omega n into d omega. So now let me substitute HD of omega, its value is, that is e power minus j 3 omega, or I can write it as HD of n is equal to 1 over 2 pi integration, as we know here signal exists only between minus 3 pi by 4 to 3 pi by 4. So it is minus 3 pi by 4 to 3 pi by 4. We have e power minus j 3 omega into e power j omega n into d omega. Further, I can represent it as HD of n is equal to 1 over 2 pi integration minus 3 pi by 4, 3 pi by 4. I will simplify this as e power minus j omega, I will write it as j omega 3, or I can write it as n minus 3 into d omega. Here e power j omega is common, so I will represent it as e power j omega n minus 3. Now let me integrate this, that is HD of n is equal to 1 over 2 pi integration of this is e power j omega of n minus 3 divided by, we have j n minus 3, we have the limit, that is minus 3 pi by 4, 3 pi by 4. Or I can write it as HD of n is equal to 1 over 2 pi, the upper limit is replace omega by 3 pi by 4, e power j 3 pi by 4 n minus 3 minus, we have e power j, this is minus because it is minus 3 pi by 4 of n minus 3 whole divided by, we have j n minus 3 n minus 3. But we know that sine theta can be represented as e power j theta minus e power minus j theta divided by j2 or 2j. So now I will try to represent this in this form as, or I can write it as HD of n is equal to we have 1 over pi. I will take this n minus 3 out of this bracket. I will write it as pi n minus 3, 1 over pi of n minus 3, and here inside the bracket I will take this 2 inside. The denominator will be 2j, and the remaining term will be, I will write it as it is, e power j 3 pi by 4 of n minus 3 minus e power minus j 3 pi by 4 of n minus 3. So this term is equal to sine theta, where theta is 3 pi by 4 into n minus 3, or I can write it as hd of n is equal to 1 upon pi of n minus 3. We have sine theta is this entire term, that is 3 pi by 4 of n minus 3, or I can write it as, therefore hd of n is equal to, we have sine 3 pi by 4 of n minus 3 divided by pi of n minus 3. Let me call it as equation 1. So now in this equation, that is in equation 1, if n is equal to 3, so in that case I can represent it as hd of n will be sine 3 pi by 4, that is 3 minus 3 divided by pi of 3 minus 3, which is nothing but 0 by 0 form, that is indeterminate form. 0 by 0 is called indeterminate form. It means it is not defined. So in that case we can simplify this using L'Hospital rule. That is, let me write here, by using L'Hospital rule, that is L'Hospital rule says that limit alpha tends to 0, sine a alpha divided by alpha is always equal to a. This is the L'Hospital rule. So therefore equation 1 can be written as hd of n is equal to, so here we can see that alpha is equivalent to n minus 3 and a is equivalent to sine pi by 4 divided by pi. So its value will be equal to a. So a is 3 pi by 4 divided by pi, that is nothing but 3 pi by 4 into 1 upon pi, that is nothing but 3 by 4. That therefore now hd of n is equal, can say 0.75, that is 3 by 4, if n is equal to 3 and its value is same, that is sine 3 pi by 4 of n minus 3 divided by pi of n minus 3, if n is not equal to 3. We should remember this. So here we supposed to use the Hamming window. The Hamming window sequence is given by, that is Hamming window sequence is given by, that is we can write the Hamming window sequence as WHM of n is equal to, we have 0.54 minus 0.46 cos of 2 pi n divided by m minus 1 where n is equal to 0, 1, 2 up to m minus 1 and its value is 0 otherwise. So this is the definition of Hamming window. So now the next step is we have to find h of n. Therefore h of n is equal to we have hd of n into we have whm of n. Therefore h of n is equal to we have hd of n, that is sine 3 pi by 4 of n minus 3 divided by pi n minus 3 into we have to multiply it with Hamming window, that is 0.54 minus 0.46 cos 2 pi n divided by m minus 1. So here we can see that this term, first term is hd of n and this term is window sequence whm of n. So now for different values of n we supposed to find h of n, that is n is equal to 0, 1, 2, 3, 4, 5 and 6 because m is equal to 7. So the n takes the values from 0 to 6. Now let's calculate h of n for different values of n. So let me consider n is equal to 0 first. Now I will find hd of n, that is this is hd of n for n equal to 0. For n equal to 0 it will be sine minus 9 pi by 4 divided by n is 0 minus 3 pi. Let me calculate this. Keep the calculator in radian mode. So here if we substitute n equal to 0 it will be minus 3. So 3 into 3 is 9, that is sine minus 9 pi by 4. I will calculate that first, that is sine minus 9 shift pi divided by 4. So its value will be this one divided by, we have here n is equal to 0 means minus 3 pi, that is minus 3 shift pi. The result will be 0.075. So hd of n value is 0.075, that is 0.075. So now whm of n for n equal to 0. So here cos 0 is 0, cos 0 is 1. In that case we'll get 0.54 minus 0.46. So 0.54 minus 0.46 is 0.08. Now let's multiply these two terms so that we'll get h of n. So here let me calculate this also, that is 0.54 minus 0.46. The answer will be, we have 0.08, that same thing we have written, into we have to multiply with 0.075. So we'll get 6 into 10 power minus 3, that is nothing but 0.006, that is 0.006. Likewise, now if we consider n is equal to 1, so now we have sine minus 6 pi by 4, 6 pi by 4, its answer will be this one, divided by, we have minus 2 pi, minus 2 pi, will get the answer as minus 0.159. 0.159. Now let me solve whm of n for n equal to 1. It is 0.54, that is 0.54 minus 0.46. We have cos, so here it is 2 pi by 6 because n is equal to 1. 2 pi by 6. So its value is 0.31, 0.31, that is 0.159 we'll get it as it is 0.04929 minus 0.04929. So now take n is equal to 2. In that case, it will be sine minus 3 pi by 4. That is sine minus 3 pi by 4, and its result will be root 2 by 2 divided by, we have, when n is equal to 2, it will be minus 1 pi. That is divided by minus 1 pi. So the result of this will be 0.225. That is 0.225. So here it is 0.54 minus 0.46 cos of, we have n equal to 2, that is 4 pi, divided by m is 7, it is 6. So the result will be 0.77. If you multiply with 0.225, we'll get 0.17325. So therefore I can write it as 0.7733. We have 3. Next, for n is equal to 3, already we have calculated, that is 0.75. So here if we substitute n equal to 3, it will be 6 pi by 6. So it will be cos pi. Cos pi is minus 1. So the result will be 1 here. So multiplying these two will get 0.75. So we know that h of n is symmetric about tau. So here tau value is 3. So it is symmetric about tau, means for n is equal to 4, it will be same as 2. N is equal to 5, it is same as 1. N is equal to 6, it is same as 0. So for n is equal to 4, it will be 0.225, and the value will be same, 0.77, and here it will be same, that is 1733. Similarly, for n is equal to 5, it will be same as minus 0.159. Here it will be 0.31, and this will be minus 0.04929. And for n is equal to 6, it is same as 0, that is 0.075, 0.08, and here it will be 0.006. Let me verify. I'll take n is equal to 5, it will be 2. So 2 into 3, 6 pi, sine 6 pi, that is sine 6 pi divided by 4, and then divided by, we have n is equal to 5. 5 minus 3 is 2 pi divided by 2 pi. The result will be minus 0.159. We got the same thing. Therefore here also it is symmetric, that is the value will be 0.31. We'll verify, that is 0.54 minus 0.46. We have cos, n is equal to 5, means 10 pi by 6. 10 pi by 6. The result will be 0.31, and multiplication of these two will be this one. So this is the h of n values. So here these h of n are the filter coefficients. Now let me calculate, as it is asked in the question that we are supposed to find hd of e power j omega, that is nothing but frequency response. The frequency response is given by the formula. We have hd of e power j omega is equal to e power minus j omega m minus 1 by 3, in bracket we have h of m minus 1 by 2 plus summation n is equal to 1 to m minus 1 by 2 to h of m minus 1 by 2 minus n cos omega n. So therefore, so here it is 2. So therefore now I can write hd of omega, that is frequency response, is equal to e power minus j. We have m is equal to 7. 7 minus 1 is 6. 6 by 2 is 3. That is j3 omega. In bracket we have h of m is 7. 7 minus 1, 6 by 2 is 3. H of 3 plus n varies from 1 to, we have summation n is equal to 1 to 3 to h 7, that is 3 minus n cos omega n. Simplifying this, hd of omega is equal to e power minus j3 omega. We have h of 3 plus 2h of n value is 1, so it is 2h of 2 cos omega plus, for n equal to 2 it is 2h of 1. We have cos 2 omega plus 2h of 3 minus 3 is 0. We have cos n is 0. N is 3, that is 3 omega. Therefore I can write hd of omega is equal to e power minus j3 omega. We have h of 3 value is 0.75 plus 2 into h of 2 value is 0.1733. 0.1733. We have cos omega plus 2. H of 1 value is minus 0.04929 minus 0.4929 cos 2 omega plus 2 into h of 0 is 0.006 cos 3 omega. So simplifying this, I will get hd of omega is equal to e power minus j3 omega. We have 0.75 plus multiplication between these two, it gives 0.3466 cos omega. So it gives minus 0.0988 cos 2 omega plus 2 into 0.006 gives 0.012 cos of 3 omega. So this is the final result, that is hd of omega. H of n are the filter coefficients.